Hi, I'm going to do some engraving on a small little circular disc, so I thought I'd show you my little CNC machine. I call it a milling machine, but it'll only mill plastic and aluminium. More of a circuit board drilling machine really, but anyway, it's okay. And I'll just go and explain what I'm trying to do, and we'll have a look at the machine at the same time. Okay, there's the little part that I'm trying to engrave. I want to engrave on the periphery every 5 degrees. I want to mark a fine mark if I can. I've built a little fixture, this little thing here, out of a bit of 1.5 inch mild steel, and it's got a 10mm register in there, which is pretty true with the axis of the rotary table. So anyway, it's got a 10mm locator in there, so let's see if you can actually see it. There we are. So it locates in there. I've got a small mark. I don't know whether you can see it, probably can't. It's just there, and I've got to line up the cutter with that. If we stand back and have a look at the machine a little bit more. Oh no. Okay, before we start, let's just have a quick look at the machine in a bit more detail. I've got the main box. I've got with all the electronics in that one down here. But I've only got a few controls. That's the speed control between a maximum right the way around to a minimum. Then you've got clockwise or anti-clockwise rotation of spindle. This one here is I've got it fixed up so I can reset the motor circuit, which tends to be less than perfect. This little toggle switch enables me to, in an emergency, disable all power or all movement to the axes. The computer still sends the signals, the motors are still activated, but there's no movement. This one is the kamikaze emergency switch, which switches off all the power to everything. Then you lose the connection between the computer and your machine. If you just use the movement toggle, the onboard microcontrollers are still okay. They're still functioning, and you can sort of work out you don't have to start all over again. Anyway, the electronics is in there. I'll show you that in a minute. Then you've got your X and Y slides with your slotted tabletop. Then you've got your spindle. Let's see if I can get that in there. You got that rotation there, sort of a simple type of chuck. It's not a collet chuck, it's just bushes that go in there, but it seems not too bad. I've got preloaded bearings in here, so there's not much spindle play, well, none actually. And then on the top you've got the bit of electronics with the slotted discs, which gives some kind of feedback. A fan, a bit of electronics there, heat sinks, and then there's the stepper motor up the top there with a fan. It all gets a bit warmish if you don't have the fans. Okay, the actual rotary table, I don't know what you call it. Yeah, we'll call it a rotary table for now. It isn't really. It's an indexable spindle, I suppose. Got your worm wheel, and you worm down the back there, and then that's driven through a stepper motor system which is connected to the box via that cable in there. So that's roughly the system. You've got the little disc is going to be mounted on there, and that's what I'm going to be engraving the marks on. I'm going to be mounting this little oh, it's a bit rubbish for focusing this machine, isn't it? Anyway, that small little engraving tool, which is going to go in here eventually when I'm ready. And also I'm going to clock the whole lot up. Let me see if I can get this without knocking the whole lot over. I've got a dial. I've just got a little magnetic base on there, on just a bit of mild steel, and just get that down a bit. I should be able to. These cameras really are crap at actually focusing, aren't they? But anyway. There we are. I wonder if you can manually focus that or something. Oh, it doesn't let me change it when you're recording. Okay, anyway, you got it on there, and I should be clocking that in next. When I've got that clocked in, then we're going to run the computer and hopefully run the program, what have you. So I'll just stop it there while I set it up in its I've got a little camera mount here. I'll just show it. It's bolted up there, and then it's got a couple of arms which I can fiddle around with and mount the camera on the end here on this bit. Anyway, I'm going to set that up so I've got something fixed and not me waving around with the camera, and then I will have a go at setting it all up. Okay, we're back in there now. Now all I've got to do is mount that on there with the threaded rod. There it is. Screw that in just to hold it back. I've plenty there, you can see it just coming out the end there. Right, just nip up the nut on the back. Okay, now first things first, got to get this running true. I'll zero it out just for a laugh. Now I'll get the machine going and rotate that so that we can clock this in and make sure we don't have any more than about a foul max deviation. So I'll just get that going. Right, while the computer's running the program and installing it, I'll just turn it on. Okay, just got to zero up the axes. Okay, they've all come up against their stops now, so we should be ready to roll. Now I have to go on the screen that says MDI, manual data input. So I want G00, go fast. What else do we want? Nothing. A 360. I want to do 360 degrees. Right, here we go. I don't expect you can see one bit of that, but anyway. It's slowly mincing its way around. It's all a bit slow, I'm afraid. Can you ever see it? It's actually out a little bit. Damn. There's the mark, so at 90 degrees it's blooming 2.5 thou out. Cutting. Coming up for 3 now. So I might be able to loosen it and just fiddle with it a little bit. So at nearly 180 degrees it's about 3 thou out, which ain't no good. Let's go right back to 0 anyway. Sorry, I can't show you the dial because it's yeah, it's coming back down to 2. One. You don't really want it running out at all. You want to get really even marks. It's coming down to 0 now. Yeah, so it's at least 3 thou. So I've got to come up or down 1.5 thou in this vertical plane by the look of it. It's actually 3.5 thou out. We're nearly there, just stop in a minute. Clunk, click. Right, let's just see if I can do it. Zero that up. Now I've got to go back to 0. So A0. Right, I'll stop this and then we'll come back when it's clocked up, but you can see the scheme of things. I've got to fiddle around with this. I think I might have cracked it actually. I'm started off at 0 there and I'm coming round to 180 and I'm half a thou at the moment, so you know, I might be lucky. Anyway, when I've got it clocked in, I'll come back to you. Okay, I've got the cutting point, the cutting tool, not at the right height yet, but I've got this clocked in within half a thou. I've got the X and Y slides positioned over the centre line of this axis. Now I've got to move the tool over a couple of millimeters and then use a couple of feeler gauges to set the depth I want. So let's do that now then. First of all, X minus 2, then Where's the feeder gauges? I had them somewhere. Right, I'll just go and get the feeder gauges, hold on. Okay, now I've got 16, a 12 and a 6, so that's 18 thou, and the first line of my program is drop this cutter down 0.5 millimeter. So if I make it 18 thou above, I drop it down 20 thou or 0.5 millimeter, I should have a cut of 2 thou. Famous last words. Right, drop it down. Okay, tighten that up. Ooh, yes. Give that an extra little fun. Okay. Now bring it back to its start position. So we want X0. Okay, I think we're ready to rumble. What else we got to do? Nothing. Just got to go to the next screen and run the program. I haven't even loaded the file up yet. Load G-code. Circular engraving. Open. Okay, we should be okay. Oh no, we've got to return the this rotary motion. I've got to return that to 0 before I start, otherwise life will be very cruel. So let's go A0. Come on baby. Wait till that's got all the way back, boringly. Right, I'll save watching this thing go round it. Like a scot at this slowly. I'll bring you back when it's round again. Okay, we should be ready to rumble now. I've just got to move the work. I've got it clocked up concentric. I've got to move that now to the point. Tip of the tool is right just clear of the work and on the right axes and so on. So I've got that set, those positions set up on G55, so I'll use the manual data input to set it to G55 and then 0 all the axes, and that should in theory move it to the right position. Famous last words. Let's have a go. G00, go as fast as we can. G55, X0, Y0. It's usually safer to do the Z last. Okay. Now we do Z0. Then we get it going when it's down. Yeah, it's clear of the work. Turn it clockwise. Right, move it down next to the next screen. Load the code. And cycle start. Famous last words, here we go. Right, this is a bit of a long job. This I upload freeway, just like a bit. bit quicker now. From 50 millimetres per minute I got it to 100. You should get it any closer than that. Further than that. Let's just try. Da, 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 da. I don't think that's any closer at all, to be honest, is it? No, I don't think I can, to be honest. The depth of the cut doesn't look too bad. Painfully slow. Take quite a time. I think the best thing to do is just let it progress, and I'll bring you back when it's nearly there. Okay, just got a few more left now. Coming up to 335 degrees, nearly there. When you look at that mark under a magnifying glass, it does make a very nice little half-round groove. It's quite good, quite a nice clean little shape. Right, it's finished the cycle and now it's going to go back to 0 relative to the machine axis rather than the work axis. There we are. Now let's have a look. Let's just brush that off. I mean, come on, that's not too bad. I mean, you can't actually. I'm going to take this off the stand and see if we can get really close to it. I don't know. Not with a GoPro, you have to be sort of sitting on top of it. Anyway, that's what we got. It's not too bad. In fact, damn good, to be honest. When I mentioned earlier that it was only suitable for doing sort of light milling and stuff, that's a little cam that I made. Let's have a look and see if you can see it. That's it. A two-lobed cam. They're the high points on both sides, and with a sharp drop and then a gradual slope. And that was used in my drilling machine. That was actually the first one I tried, and it was done on this machine. But it was, I've done it all wrong, you know, the depth of it was all wrong. So anyway, I did it okay on the second one. So this one was a scrap one, but I don't know whether I'd fancy making that by hand, you know, accurately. And this machine did do it painfully slowly, about 0.5 millimetre ago, but it did do it. And it's a complicated shape, you know, with sort of weird looking slopes and stuff. So, you know, it's quite a difficult thing to hold. It was actually on this bit of steel. It was pushed on there with another bit that held it. Anyway, that's, so it has been you know, quite a good addition to the workshop. The other thing I meant to show you is the inside the cabinet, you know, the electronic bits, if I can get hold of it. Here we are. It's a bit of a nightmare wiring, and Christ knows what. Basically, if I can go from one end, you've got the you know, the inputs, the connection to the parallel port, the wires from the parallel port come up to this one, so that's the interface. It's got a couple of chips in that bring it to TTL values. You've got your two transformers, one that provides 24 volts and the other one 50 volts for the motor. Then you rectify those and distribute them to all the boards, and these are my, each axis has one of these boards. I did have a proprietary you know, stepper driver board, but I don't know, they cost 30 quid each, but they went wrong. They overloaded them or overheated or did something or other. Anyway, I made my own in the end. It's much better because then you can write your own program for doing the stepping. So I've got micro stepping. The battery's just going to go wrong. Yeah, okay, so it's not too bad. That's the motor one, and that does the pulsing and also the feedback from that slotted discs comes to these two chips here, which supposedly make you better. They do. If you didn't have any feedback, as the load on that DC motor, it would just stop, whereas at the moment, as it detects a slowing of the speed, it widens the pulse, and you do stop it stalling, so it is better. Anyway, it's a bit of a nightmare getting all that lot in there, but anyway, massive great box, but you still fill it up. Anyway, that's my etching achievement so far. The actual grooves and such are nice and accurate, and although they're not of the finest, they're not too awful, are they? You know, they're not too wide. Sharpening that little cutter to an even finer point would be a bit of a nightmare, so it's probably the best I can do, but anyway, I'm quite happy with it. Anyway, thanks for watching, and I'll see you soon.